Now we're going to start multiplying polynomials by polynomials, not just a monomial. And so the first example we want to take a look at is going to be probably our most common, just a binomial times a binomial. Bi. Not sure if you guys know that NSYNC song. Bye, bye, bye. All right, a binomial times a binomial. We'll start off with 8n minus 4 times 5n plus 7, okay? Your initial instinct is just going to be to multiply our first terms and our last terms, but that's not how this works. I'm going to show you a method that I think is going to be the most helpful, not just for now, but also later on down the road when we eventually have to undo this process, okay? We're going to set up a box. We're going to break that box into four spots, okay? Now along the top of the box, I'm going to put this first binomial, 8n minus 4. Now on the side, we'll do the other binomial, 5n and 7. And now from here, it's actually pretty straightforward. We're going to do 5n times 8n to go into this box, so 40n squared. 5n times negative 4, negative 20n. 7 times 8n, we have 56n, and 7 times negative 4, negative 28. So once we multiply this, our next step is going to be combine like terms. And so if you want to pull out the terms first, this is totally fine. So 40n squared minus 20n plus 56n minus 28, and then combine like terms. Negative 20n plus 56n. We end up with 40n squared plus 36n minus 28, okay? This is how we do this. Every time we multiply a polynomial times a polynomial, we can use this box method, okay? It's pretty easy to set up, and don't cut corners, okay? Especially as we're learning this, do not cut corners, okay? So before we move on, I'm just going to show you the wrong way. I'll show you how wrong it is. Okay, this is wrong. A lot of you, when you do 8n minus 4, I'm going to outline that example I mentioned for 5n plus 7. A lot of you are going to multiply these first two. We end up with 40n squared. You multiply this last two, minus 28. You're missing this whole middle piece, okay? And that's why that's not right. We have to multiply the entirety of the first binomial by the entirety of the second binomial. That's why this is wrong, okay? So let's take a look at another example. Nothing too crazy, where we have 6a minus 5 times 6a plus 3. Let's set up our box. I'm actually going to make my box a little bit bigger this time. To whatever size you need. Okay, so I have 6a, negative 5, 6a, 3. 6a times 6a, we multiply those, that is 36a squared. 6a times negative 5 is negative 30a. 3 times 6a, that's 18a. And 3 times negative 5, that's negative 15. So we pull those terms out. We have 36a squared minus 30a plus 18a minus 15. Minus 15. Okay. So we end up, when we combine like terms, 36a squared minus 12a minus 15. Okay. Nothing too crazy there. All right. So I want you to try 2 on your own. Okay. The first one is 7a minus 2 times 2a minus 4. The next example is going to be 6p plus 3, and then 4p plus 2. Okay, go ahead and work these two out. All right, so here are the answers to those two problems. If you need to pause it and just check over your work, go ahead and do so. In the meantime, we're going to take a look at what it means to do a binomial times a binomial when we have two different variables. We won't be dealing with this nearly as often, but it is still a good skill to have. So it's still going to be pretty useful for us. We have 4x plus 2y times 4x minus 4y. Separate box. Four x 2y, 4x negative 4y. Make sure you're not forgetting about that negative, especially on the vertical one. So multiply 4x times 4x is 16x squared, 8xy, negative 16xy, and negative 8y squared. So 16x squared plus 8xy minus 16xy minus 8y squared. We need to check to see if they have the same, if they're like terms here, and xy's do match up. So we end up with 16x squared minus 8xy minus 8y squared. Okay. We're going to do one more example of one more type of problem, and then you'll be on your way. Okay. Now we're going to be doing a bi, try. So binomial times a trinomial. The box method will work for any size polynomial by any size polynomial, but we won't be dealing with much larger than this. We have n plus 1 times 2n squared plus 7n minus 3. Let's set up our box. Okay, I think I made my box a little small, but no worries. Okay, I did mine as a 3 by 2. You could have just as easily done a 2 by 3. It's up to you. But we have n1, 2n squared, 7n, negative 3. Okay, luckily I picked a 1, so this will be pretty easy. Remember, the coefficient of this is just 1, so we have 2n cubed, 7n squared, negative 3n. We have 2n squared, 7n, negative 3. So this is where it's going to be really helpful to pull out all those terms. 2n cubed plus 7n squared minus 3n plus 2n squared plus 7n minus 3. So is there anything with 2n cubed? No. 2n cubed. We've dealt with that. 7n squared. Now we have 2n squared. So that's plus 9n squared. Negative 3n. Now we have positive 7n, so plus 4n. And nothing left but that minus 3. Okay. Combining like terms is probably the spot where most people screw up. So just make sure you're really paying attention to those exponents and you combine them correctly. Remember, the number includes the sign in front of it. So this is a -3n, not a 3n. So we had -3n plus 7n. That's how we got that positive 4n. We'll leave you with 2 to do on your own. One of them is a binomial times a trinomial, and the other one is a trinomial times a trinomial. I'll help you get them set up, and then I'll let you do it. So we have a v minus 3 times 8v squared minus 7v minus 2. So I'm going to help you set this up. I'm just going to make it even bigger than I think I really need. Okay. V negative 3, 8v squared minus 7v minus 2. Okay. There's that problem. And now we have this problem. We have 5x squared minus 4x plus 2 times 7x squared plus x minus 4. We're going to set up a 3 by 3 box. I would say as you're doing these, make a bigger box than you think you're going to need. Okay. There we go. And so on the top, I'm going to put 5x squared, negative 4x, 2, 7x squared, x, negative 4. If you swapped places of these two, it would be totally fine. There'd be no problems.